Okay, so here we are in question 1. The diagram shows the graph of y equals a sine bx plus c between negative 360 and positive 360, where a, b, and c are constants, which we need to find. Okay, now all of these questions are often identical, and it really hinges on whether or not we understand what a, b, and c here actually refer to. And so what I'm going to do is I'm going to try to explain that. I'm going to go through it in reverse order. So C, what does that C mean? It means the shift in the y direction. And that basically tells us where the center line is, right? So the center line is the horizontal line that the sine or cosine wave oscillates about. So in this case, hopefully you can see the center line is going to be -4. Now, if you're absolutely not convinced why that is the case, a foolproof way you can use is you can always look at the peak value, which here is -1, and the trough value, the lowest value, which is -7, and you want to find the value that's halfway in between that. So you could add up those two values, -1 plus -7 is -8, and divide by 2, which will give you -4. Okay, so here we can see that C must be equal to -4. So C is equal to -4. All right, now, what does B refer to? Now, B is the one that causes people the most trouble, and a lot of my students tell me it's the period. Now, B is not the period. It's related to the period, but it is not the same thing. B tells us the number of waves in 360 degrees, or if we're using radians, 2 pi radians, right? So if B is 2, that means that there are 2 waves in 360 degrees. If B is 3, it means there are 3 waves in 360 degrees. And so this is going to be related to the period, which is the size of each wave, using this formula, right? T will be equal to 360 degrees divided by B. Now let's just think that one through for a second. If B is 2, that means there are 2 waves in 360 degrees. So what will be the size of each wave? It will be 360 degrees divided by 2, right? 180 degrees. If B is 3, what does that mean? It means that there are 3 waves in 360 degrees. So how big is each wave? It will be 360 degrees divided by 3, 120. Okay, so the size of each wave is the period, and it's related to this, this B number, but they are not the same thing. Okay, so how are we going to do this? Well, looking at this graph, it's actually quite difficult to tell the size of one wave. But what we can do is we can start here, right? So let's start there, and we can go all the way up to here. Can you see that? That is one full wave, right? One full wave goes from there all the way up to there. And so what we need to do is we need to know what these values here are, right? We need to know what those values are. Okay, and we know that this is 180 or -180, so that's got to be -90, right? And so if we move another 2 steps, we're moving 90 degrees to the left. So this here is going to be -270, right? And that's -90 there. So similar argument, that's 90, and that's going to be +270. So what's the period of the wave? Well, it's going to be 270 plus another 270, which will be 540. So we know that in this particular case, that the time period is equal to, or the period rather, is just 540 degrees. So what will B equal to? Well, if we just rearrange this equation here, B is going to be equal to 360 degrees divided by 540. And we can cancel off, can't we? Because I'll divide top and bottom by 10, like that. I've got 36 divided by 54. Well, if you're not sure how to do that, you could use a calculator, but I'll divide top and bottom by 2, which is 18, and 27. And I'll divide top and bottom by 9, which will give me 2 upon 3. So B is equal to 2/3. Okay, so B is equal to 2/3. Let's put that up here. B is equal to 2/3. Then lastly, what does A refer to? Right? What does A refer to? Well, A is the amplitude. It is the distance, the vertical distance from the center line up to the peak or down to the trough. So here's the center line. How far do we go up to get to the peak? Well, we go up by 3, don't we? And how far do we go down to get to the trough? Well, we go down by 3. So the amplitude there is equal to 3. Okay, so there you go. That's 3 marks available there. I think those questions really, some students do find them difficult, but I think so long as you're very careful to understand what each of those letters A, B, and C refer to, I don't think there should be too much of a problem there. So make sure that you really get to grips with that, especially that letter B. Make sure that you are completely clear in your own mind what that refers to. All right, then question 2, which is a logarithm question. Given that log base 3r plus 2 log base 9s is equal to 8, find the value of r times by s. Well, the first thing we should notice here is we've got 2 different bases. We've got a base of 3, we've got a base of 9. So we're going to need to change one of these logarithms into a different base. We either change log base 3 into a log base 9, or we change log base 9 into log base 3. And generally speaking, guys, it's easier to go from a higher base to a lower base. So I'm going to choose to change log base 9. Now, we need a reminder, actually, what is the change of base formula? Well, let's say that I've got log base A of x, and what I want to do is I want to convert it to log base B of x. Well, the way I would do that is I would divide through by log base B of A, which is the old base. Okay, so this is the formula for the change of base, and essentially, if you want a way of remembering it, on the right-hand side, the numerator and the denominator have the same base. Okay, I think that's a good way of doing it. Now, how can we apply this? What's this actually going to mean? It means that if we take log base 9 of s and we want to change it to log base 3 of s, then we are going to divide it by log base 3 of 9. And log base 3 of 9 is 2. Why is that? Well, because what power do I have to give 3 in order to get 9? I give it a power of 2. So now that I've done this, I just substitute into my equation. So I get log base 3r plus 2 times by log base 3s over 2 is equal to 8. And of course, the 2's there cancel off, cancel. So I've got log base 3r plus log base 3s. Well, we can use the logarithm rule that log a plus log b is log a times by b. Okay, and so that there is equal to 8. Okay, then it's just a matter of converting it to exponential form. Rs is equal to 3 to the power of 8, right? So we take our base 3, this is our power 8, and then 3 to the power 8 is 6561, and that should be our answer. Okay, then question 3, given that y is equal to a half tan x, find the exact value of dy dx when x is equal to pi by 3. Okay, so we've got to differentiate tan a half x, so I'm going to write that as y is equal to tan a half x. Okay, and then this is a chain rule because we've got one function, which is a half x, inside another function, which is tan. So if we differentiate the big function first, if we differentiate tan, we will get sec squared. So we get sec squared a half x. Then we've got to differentiate the function on the inside, which is a half x. And if we differentiate that, we get a half. So we multiply through there by a half. Sorry, I'm just going to change that a tiny bit because it looks like 1 upon 2x. So I'll just write that as a half x there to make it a bit more clear. Okay, then. So now what we're going to do is we're going to substitute x is equal to pi by 3. So when x is equal to pi by 3, okay, then dy dx is going to equal to a half, beg your pardon, sec squared, a half of pi by 3, which is pi by 6. Now, what is sec equal to? Well, we always look at the third letter of cosec, sec, and cot. So 1, 2, 3, that's the third letter is C. So sec is 1 divided by cos. So this thing here is actually the same as 1 upon 2 times by 1 upon cos squared pi by 6. Okay, nice and slow. And what's cos of pi by 6? Well, you can type into your calculator, but it's probably a good thing actually if you're able to memorize those angles because it's a critical angle. You will get root 3 upon 2. So this is 1 divided by root 3 upon 2 all squared, okay, because it's cos squared. And so then if we square that out, we're going to get a half times by 1 upon 3 upon 4, right? Because root 3 squared is 3, 2 squared is 4. So now if we multiply out the denominators, we get 1 times by 1, which is 1, and 2 times by 3/4 is 3 upon 2. So we get 1 upon 3 upon 2, and 1 upon 3 upon 2 is the same thing as 2/3. Okay, so do you notice, by the way, how I did it all of those steps nice and slowly, nice and patiently? What I didn't do, which a lot of people do, is I just whack this into a calculator here, okay? Because actually when you type longer things into calculators, it's quite easy to get things wrong. Whereas if you kind of do it yourself and you do it nice and patiently, I think actually you're more likely to get it right because you go through each step by yourself. The other thing I would notice is that a lot of students, they forget to change their calculator to radians. And that means they get this weird decimal like, whatever, 0.45972, blah, blah, blah. If you've got an answer like that, your brain needs to kick in and say, hang on, wait a minute. Should I have been using radians here? Have I set up my calculator properly? So that's the only other thing that I would say just from noticing my students in the past. Okay. Okay, then question 4, combinations, permutations. Question, a team of 8 people is to be formed from 6 teachers, 5 doctors, and 4 police officers. Find the number of teams that can be formed. Okay, with all of these questions, the key thing you need to do first is determine whether or not your permutations, NPR, or combinations, which is NCR. Okay, now what does NPR refer to? It is the number of ways to arrange R items taken from N. Okay, sorry about the bad handwriting. Whereas combinations is the number of ways to choose R items taken from N items. Okay, so the key difference really is between the word arrange and the words choose. Now, arrange means that there is an order. Choosing means that there is no order. It doesn't matter. Okay, so permutations, basically, the key difference is, does order matter? And if order matters, we use permutations. If order doesn't matter, we use combinations. And we always need to ask that when we're doing these kind of questions. So, for example, if we're arranging books on a shelf, then there is an order in which we put the books. Therefore, we use permutations because order matters. If we are selecting people to be in a team, right, then we use combinations because the order in which we choose the people doesn't matter. Unless, let's say, we're choosing a team of people to perform in a play. Because if we choose a team of people to perform in a play, in a way, the order matters, right? Because we are allocating people to particular roles in the play. Okay, so we allocate one person to be Othello, the other person to be Desdemona, the other person to be Iago, and so on and so forth, right? So in that particular case, order matters because choosing the first, second, and third person to be Othello, Desdemona, Iago is different to choosing Desdemona, Iago, Othello, okay? So you cannot basically think of it as, oh, this has got people, therefore it's combinations, or hey, this is to do with books, therefore it's permutations. You can't think like that. You need to think in this particular context, does the order matter? Okay, now let's try to think that through in this particular case. We are choosing a team of 8 people taken from 6 teachers, 5 doctors, 4 police officers. That's 15 people in total. Is the order in which I choose them going to matter? No, right? Because there's no indication that they are performing a particular function in the team. They're all doing the same thing. So in this case, I'm going to be using combinations. And so what am I doing? I'm choosing 8 people from 15 people. So that answer is going to be 15C8. and 15C8 is 6435. Okay, that's that. Find the number of teams that can be formed without any teachers. Well, if there are no teachers, I can't choose from these 6 people. I've only got to choose from these 9 people. And so I'm choosing 8 people from 9 people. So that's going to be 9C8. And 9C8 is just equal to 9. All right, then part C. Find the number of teams that can be formed with the same number of doctors as teachers. Well, let's put it as a list, I think, or kind of put it in a table or a grid. So you want to be able to think through this kind of question systematically. Teachers, doctors, and police officers. Okay, and we want the same number of teachers as doctors, right? So these 2 guys have got to be the same. Now, let's think about it. How many police officers do we have? We have got 4 police officers. Okay, well, let's say that we started by having all 4 police officers. If we had all 4 police officers and we want to choose 8 people, then that means we've got to choose 4 remaining people. And if the teachers and the doctors have got to have the same amount, that means 2 each. So this is going to be 2 and 2. Okay, now let's say that we chose 3 police officers. Well, that means we would need to choose 5 remaining people. But hang on, we can't then choose an equal number, right? Because 5 can't be divided by 2. So we can't have 3 police officers. Well, then let's say we've got 2 police officers. That means we've got to choose 6 remaining people. And if we choose 6 remaining people, that will be 3 each there. And then the last case, well, obviously we can't have 1 police officer for the same reason. We'd have to choose 7, and 7 can't be divided by 2. So we've got 0 police officers, and that means we'd have to choose 4 teachers and 4 doctors each. Okay. Now, if we go back up to the top, we had 6 teachers, 5 doctors, 4 police officers. So I'll just kind of put that in brackets there so I can see 6, 5, 4. Okay. So we've got 3 cases to consider. We've either got this case here, case 1, or we've got this case here, case 2, or we've got this case here, case 3. Okay. And basically then we've got to decide for each case how many ways can we do it. So how many ways can we get 2 teachers from 6? Well, that will be 6C2. How many ways can I get 2 doctors from 5 doctors? That will be 5C2. And how many ways can I get 4 police officers from 4 police officers? That will be 4C4. Now, I need to have 2 teachers and 2 doctors and 4 police officers. And so here's a general rule. If we've got an and, right, if we want 2 things to be happening at the same time, then we need to multiply. Whereas if we've got an or, right, if we've got, for example, one case or another case, then we are adding. So in this particular case, in this particular situation, what I'm saying is we want to have the 2 teachers, the 2 doctors, and the 4 policemen. So therefore, we are going to be multiplying these numbers together. Okay, that's case 1. Okay, and if we multiply that all out, we get 150. Okay, case 2, we want to have 3 teachers, 3 doctors, 2 police officers. How many ways can I choose 3 doctors from, sorry, beg your pardon. How many ways can I choose 3 teachers from 6 teachers? 6C3. Same thing for 3 doctors from 5 doctors. That would be 5C3. And how many ways can I choose 2 police officers from 4 police officers? 4C2. And if I multiply that all out, I get 1,200. And then lastly, I do the same thing for the last row. So this will be 6C4 ways of choosing the teachers, times by 5C4 ways of choosing the doctors, times by 4C0 ways of choosing the police officers. Like that. And if I multiply that all together, I get 75. Now, I can either have this case or this case or this case. So if I have or, what do? I add them all up. So what's going to go on here is I'm going to add up all of these numbers. And if I add up all of these numbers, I get 1425. Okay, and that will be my final answer. So let me just check that against the mark scheme, make sure I am right. 1425. is the correct answer. All right, question 4 here. The diagram shows the trapezium ABCD. The lengths are shown. So we got here 9 root 7 minus 9, root 7 plus 2, and 8 root 7 minus 7. We want to find the perimeter of the trapezium, giving our answer in its simplest form. Well, in order to find the perimeter, basically, we just need to find that length there, right? That's the only length that's left over. So how are we going to do that? Well, I think the best thing here to do is we want to create a nice right angle triangle. Okay, like that, because then we could use Pythagoras law or Pythagoras theorem to find the length of AD, because we know that this length squared plus that length squared must be equal to that length squared. Okay, now the vertical line's cut quite easy, right? Because that is just root 7 plus 2, right? That is exactly the same as that length there. But what's this length here going to be? Well, it's going to be the whole 9 root 7 minus 9 minus the 8 root 7 minus 7. Now, I think we want to be a tiny bit careful about doing this. So, whatever, I'll call that length x, shall I? Just x like that. So what I'm saying is x is equal to 9 root 7 minus 9 minus 8 root 7 minus 7. The reason I'm using brackets, right, is because I think a common mistake will be to forget that you're doing minus 7 here, right? So I think that's an error. So I'm always careful to put the brackets to make sure I don't slip up. Okay, so what have I got here? I've got 9 root 7 minus 8 root 7, which is just 1 root 7. And I've got minus 9 minus minus 7, so that's minus 9 plus 7, which is negative 2. Okay, so that length there, x, is actually root 7 minus 2. So let's write that down. This is equal to root 7 minus 2. Okay, then now we can use Pythagoras theorem, right? So Pythagoras theorem will tell us that the length of AD all squared is going to be equal to root 7 minus 2 all squared plus, I think it was root 7 plus 2. Yeah, root 7 plus 2 all squared. And let's square it out. So we're going to get here root 7 times root 7 is 7. We're going to get root 7 times by negative 2, which is minus 2 root 7. We got it twice. That's minus 4 root 7. And then negative 2 times negative 2 is positive 4, right? Please do not fall into the trap of doing root 7 squared is 7, negative 2 squared is 4, and forgetting that middle term. That is such a common error. Next, we expand the other bracket. So root 7 times root 7 is 7, plus 4 root 7 again, and then plus 4. Okay. All right, then. Hopefully what you can see is the negative 4 root 7 and the positive 4 root 7, they cancel each other off. So we're left with 7 plus 4 plus 7 plus 4. So 7 plus 4 is 11. Doubled is 22. Okay. And so therefore the length of AD is going to be equal to the square root of 22. Right, that's that. So now if we go back to our diagram, the perimeter here, let me maybe just, I'll try to write it on the side so we can keep track of all the numbers. The perimeter is going to be equal to the 8 root 7 minus 7, like that, plus the root 7 plus 2, plus the 9 root 7 minus 9, and plus the root 22, isn't it? Right, which is at the end, right? So in other words, what I've done is I've done that length, plus that length, plus that whole length, plus that length there. All right, so let's go through each term. 8 root 7 plus root 7 is 9 root 7, plus another 9 root 7 is 18 root 7, I think. 18 root 7. And then we've got minus 7 plus 2 is minus 5. And then minus 9, I think would be minus 14. And then plus root 22. Okay, so now what I'm going to do is just going to check the answer against the mark scheme, see if I've got that all right. So what did they get? They got 18 root 7 plus root 22 minus 14. Yep, which is what I've got. Okay, all right. Then the next part is we want to find the area of the trapezium, giving our answer in the form p root 7 plus q, where p and q are rational numbers. Well, and we just used the formula for the area of a trapezium, right? So the area of a trapezium is going to be given by a half of this length plus that length times by that length, right? So let's just go across. Area is going to be equal to a half of, right, let's make sure we get this right, 9 root 7 minus 9. So 9 root 7 minus 9 plus, what was it? 8 root 7 minus 7. So 8 root 7 minus 7. And then all multiplied through by root 7 plus 2. Okay. All right, so that is a half. Okay, so we've got 9 root 7 plus 8 root 7, which is 17 root 7. We've got negative 9 minus 7, which is negative 16. And this is all going to be multiplied through by root 7 plus 2. So root 7 plus 2. Okay. All right, so now we've got to basically multiply out that bracket, I think. So we've got a half here. Okay, so if we were to expand all this, we're going to have 17 root 7 times by root 7, which is going to be the same thing as 17 times by 7, right? Because root 7 times root 7 is 7. Then we're going to have 17 root 7 times by positive 2, which is 34 root 7. And then we're going to have negative 16 times root 7, which is negative 16 root 7. And then we're going to have negative 32. Okay? All right, so let's try to simplify all this. So 17 times by 7. Okay, I'm going to do 10 times by 7, which is 70, plus 7 times by 7, which is 49. 34 root 7 minus 16 root 7. Okay, that will be 18 root 7. Right, because 34 minus 14 is 20, and I've got to subtract another 2, and then minus 32. Okay, all right. How will I do this one? I think what I'll do is I'll do 49 minus 32, which is going to be 17. And then 70 plus 17 is 87. So I'm going to have a half bracket 87 plus 18 root 7. Well, that looks okay. And then I can expand out with the half, so it's 87 upon 2 plus 9 root 7. Okay, and let me just double check, see if, again, that is right with the mark scheme. 87 root 2, 87 over 2 plus 9 root 7. Yeah, which is what I got. So that is the correct answer. All right, then part C, find cot DBC. Giving your answer in the form r root 7 plus s, where r and s are simplified rational numbers. Okay, so we're interested in the triangle DBC. So let's identify what that is on the diagram, I think. So I'll draw that in blue. So D to B to C like that. So we're interested in this triangle here, this one in blue. And DBC is that angle there. So I'll call that theta, I think. And we're asked to find cot DBC. Well, cot, right, we always look at the third letter of cot, cosec, and sec. 1, 2, 3 is T. So cot is 1 divided by tan, okay? So why don't we start by finding tan of theta? And tan, of course, is opposite over adjacent. So the opposite side is 9 root 7 minus 9. It's that guy. Okay, so 9 root 7 minus 9. Over the adjacent side, which was root 7 plus 2, that side there. Okay, so root 7 plus 2. And so therefore, cot will be the reciprocal of that, right? Because it's 1 over tan, so it'll be root 7 plus 2 divided by 9 root 7 minus 9. Now I'm going to factorize out the 9 out of that, I think, because that will make my life easier. In general, in AdMath, I want to factorize early and often. Okay, that's generally a good principle. Okay, so now what we want to do is we want to rationalize this. Okay, so the way to rationalize it was we look at the denominator, which is root 7 minus 1, and we're going to multiply it by the conjugate, which is root 7 plus 1. And the reason we do that is because when we multiply that out, the root 7s are going to disappear. Okay, so I multiply top and bottom by root 7 plus 1. All right. If we do that, on the top, what we'll get is root 7 times root 7, which is just 7. Root 7 times by 1, which is root 7. 2 times by root 7, which is 2 root 7. And 2 times by 1, which is 2. And then we'll keep the 9 separate for the moment. We'll have root 7 times by root 7, which is 7. Root 7 times by positive 1, which is positive root 7. Negative 1 times root 7 is minus root 7. And negative 1 times by positive 1 is negative 1. So as I said, the root 7 and the negative root 7, they cancel each other out. And so then what we're left with is on the top, 7 plus 2, which is 9. Root 7 plus 2 root 7 is 3 lots of root 7. And on the bottom, we've got 9 times by 7 minus 1 is, not 7 minus 1, my goodness, 7 minus 1 is 6, isn't it? Okay. And then I think we can divide top and bottom by 3. So if we do that, we will get 3 plus root 7. And if I divide the 9 by 3, I get 3. So then 3 times by 6 is 18. Okay. And then what do we want? We want it in that form there. Okay. So this is going to be the same thing as 3 upon 18, which is 1 upon 6, plus root 7 upon 18. Okay. And so therefore, if I write it out in the way they want, r plus times root 7, that is going to be an 18th of root 7 plus a 6th. Okay, so that's what I get. Let me just check that against the mark scheme. Go up, let's see. Where am I looking? There I am. Yeah, an 18th of root 7 plus a 6th is the answer. All right, then, question 6, which is a circular measure style of question. The diagram shows a circle with center of O and with a radius of 5. So here to here is 5, there to there is 5, there to there is 5, and there to there is 5. The points A, B, C, and D lie on the circumference. Angle DOC, this one here, is theta. And angle AOD, so AOD, is the same thing as angle COB, is equal to a half. So I think I will just indicate that onto the diagram. So that guy there is a half, and that guy there is also a half. Okay. The length of the minor arc DC is 3.75. So this arc here is 3.75. So we want to show that theta is equal to 0.75. Well, that should be fairly straightforward. Basically, in these questions, there are only two formulas that you need. You need the first one for the arc length is equal to r times by theta. And the one for the area of the sector is equal to a half r squared theta, right? Those are the two things you need. And the caveat for that is the angle theta must be in radians, okay? So here, what have we got? We have got an arc with an angle of theta with a radius of 5, produces an arc length of 3.75. So we just write that in. S is equal to r theta, which means that 3.75 is equal to 5 times by theta. And so then what we've got to do is 3.75 divided by 5. And lo and behold, we get 0.75, right? So theta is equal to 0.75 radians. Okay, so that's the first part, hopefully relatively straightforward. Next, we want to find the perimeter of the shaded region. Now, that's going to cause us a little bit more trouble. Now, let's try to think about it. In order to get the perimeter of the shaded region, what we need is we're going to need to find this arc length here, AD. Okay, well, we can do that using the formula r theta. And this arc length here, BC, which is going to be the same, isn't it? We're going to need to find that length here, which is the side of the triangle OCD. And we also need to find this length here, right, which is another triangle OAB, right? So let's try to do all of those things together. So firstly, so let me just clear up some space. Sorry about that. Let me just get rid of that. We'll assume that that's done. Let's find the arc AD, because that's the easiest thing, is equal to R, which is the radius 5, times by theta, which is a half. So that's going to be equal to 5 upon 2. Okay, so AD, this length here, is 5 upon 2. And that's the same thing as this guy, which is also 5 upon 2. All right, so now let's try to find out DC. We can do DC using the cosine formula, the cos rule, basically, which is the following. DC squared is equal to, so this length here squared is equal to this squared plus this squared, so 5 squared plus 5 squared, minus 2 lots of 5 times by 5 cosine of the angle, and the angle is 0.75 because we calculated that earlier. All right, 0.75 is 3/4. So let's simplify that. We've got 5 squared plus 5 squared, so it's 25 plus 25 is 50. Minus 2 lots of 5 times by 5. 5 times by 5 is 25, times by 2 is 50, so minus 50 cos 3/4. Okay. Just rewrite that a little bit, cos 3/4. Okay, and so that's going to give us the length DC. So we've kind of got that now. Of course, we'd have to square root it. So now what we want to do is want to find the length AB. Well, AB is going to be found in exactly the same way. So AB squared, right? This length squared will be equal to that length squared plus that length squared minus 2 lots of that length times that length, the cosine of this whole angle. So let's write that out. AB squared is equal to 5 squared plus 5 squared minus 2 lots of 5 times by 5, the cosine of theta plus 1. So you've got 3/4 plus 1, which is 7/4. Okay, and again, if I was to do that, that would be 50 minus 50 cosine 7 upon 4. All right then, so what's the perimeter going to be? The perimeter is going to be equal to 2 lots of the 5 upon 2. So we've got 5 upon 2 plus 5 upon 2 plus the DC thing. So it's going to be the square root of 50 bracket 1 plus cos 3/4 plus the length of AB, wasn't it? Which is the square root of 50 bracket 1, not 1 plus, sorry, beg your pardon, made a mistake there. It's 1 minus, isn't it? Do beg your pardon. Minus 1 minus cos 7 upon 4. All right, so I'm going to key all this into a calculator, basically. So 1, got to make sure my calculator is set to radians first. That would be an intelligent thing. Radians, okay. So cos 0.75, okay. 1 minus that equals times by 50 equals, and then square root that answer. Now we're going to add on to that the square root of, right, 50 bracket 1 minus cos 7/4, which is 1.75, close bracket. I hope I've got all that right. Let's make that equals, bam. Syntax error, how irritating. Okay, let me just, sorry guys, let me just try that again. Oh dear, square root of 50 bracket 1 minus cos of 0.75. I need to close bracket twice. That's where I went wrong. Plus square root of 50, open bracket, 1 minus cos 1.75, close bracket. Okay, let's find that equals. Good. And I need to add the 5, which gives me 16.338. So I think the perimeter should be 16.3. So we usually have to leave it to 3 significant figures. Let me just check the mark scheme, see if I've got that right. Oh, where is it? 16.3. Okay, so I've got that answer correct. 16.3 cm. Okay, jolly good. Okay, then part C of this question, we want to find the area of the shaded region. Okay, well, this thing here is the area formula, isn't it? But really what we need to do is we need to piece together how we can find that shaded region there. So that's going to take a bit of work. What I think is going to be the best thing is we find the area of the whole big sector first. So let me kind of put that in green there. So that's that big sector there. That thing there. And then we can subtract off this triangle here, right? So that triangle there. And then what we would like to do is we would like to subtract off this kind of little blue region here. Okay, so getting that blue region is probably going to be the harder one. So let's get the area of the green guy first. So let's do that. So the area, I'll call it area green. Okay, is going to equal to a half r squared, so radius squared, 5 squared, times by theta, and that angle is going to be the 0.75 plus 1, so 1.75, or 7 upon 4. Okay, so if we do that, we're going to get 5 squared times by 7, so 5 squared times by 7, and then divided by 8. Okay, so 175 upon 8. So 175 upon 8 is the area of that little green region. Okay, how can we get the area of the red? Area of the red? Well, that's going to be the area of a triangle, right? So the formula for the area of a triangle is a half BC sine the angle. So we've got a half of that length times by that length. So a half of 5 squared times by sine of that angle, which is sine 7 upon 4. Okay, so I'll write that out. That is 25 upon 25 on 2 sine of 7 quarters. Okay, so we've got the green, we've got the red. So now the only thing we need to do is we need to find that blue region here, right? This blue region. So how can we do that? Well, the blue region is going to be the sector, that guy, minus the area of this triangle. Okay, so the sector OCD minus the triangle OCD. So how can we do that? Let me go down here. So the area in blue is going to be equal to the area of the sector, so a half r squared, 5 squared times by the angle, and the angle in this case is just theta, which is 3 quarters or 0.75. Minus the area of that triangle, which is a half BC, so 5 times by 5, sine of that angle, which is 3 quarters. So if I do that, I can factorize out the 5 squared upon 2, so it's going to be 25 upon 2 times by 3 quarters. 3 quarters minus sine of 3 quarters. Okay, and I think we can now just piece all of this together because what I said at the beginning is that the area of that shaded region is going to be the same thing as the area of the whole big green sector minus the area of the red triangle minus the area of that little blue sliver there. So let me piece all of that together. The total area of the shaded is going to be equal to the area of the green, so 175 upon 8, 175 upon 8, minus the area of the red, which is 25 upon 2, so minus 25 upon 2, sine 7 upon 4, minus the area of the blue, which is going to be 25, 25 upon 2 bracket 3 quarters minus sine of 3 quarters. Okay, so now what I'm going to do is I'm just going to punch all of that into my calculator. So let me just try to do that. I will probably start on the right hand side. So I'll find sine of 3 quarters, so sine 0.75, close bracket. And then 3 quarters minus that answer, okay, and then times by 25 upon 2, okay, and then I'll add that to the 25 upon 2 sine 25 upon to sine 1.75. Okay, so if I do that, that should give me the total area that I need to subtract off. And then lastly, I do 175 divided by 8 minus that answer. If I do that, I get 8.72. 8.72, whatever it will be, centimeter squared. Okay, I'm just going to check that against the mark scheme, see if I'm right. Where am I? 8.7. Okay. Oh, why have they not given it to 3 significant figures? What's the reason? Did they tell us in the question? They didn't tell us in the... Wait, hang on. They didn't tell us in the question. So I'm not really sure why it's just given to 2 significant figures in the mark scheme. If you know the reason, could you just drop a comment down below? That'd be really great. But the key thing really with this question, guys, is to think it through in terms of how the shapes all fit together. If you can get that, then this really quite difficult problem on the paper becomes a lot simpler. Okay, I hope that was helpful. All right, question 7. The line y equals 3x minus 2 intersects this curve here at the points A and B, and the point C with coordinates blah blah lies on the perpendicular bisector of the line AB. Find the exact value of k. Okay, now with all these things, right, it's whatever it is, it's 3 sentences long, but it's worth 9 marks. And so those 3 sentences are very dense. There's a lot of work that we need to do. However, with all big complex problems, the best thing to do is always to simplify it as much as possible, right? So we want to go through each little bit one by one. So first of all, we've got this line intersecting the curve at the points A and B. So what we're going to need to do is we've got to find A and B. And how do we find those points of intersection? Well, it's the same thing as solving simultaneous equations. So I'm going to take this line here and I'm going to substitute it into the curve. So if I do that, I'm going to get 2x squared minus x times by 3x minus 2 plus y squared, which is 3x minus 2 squared, is equal to 2. So now let's expand all that. We're going to get 2x squared minus 3x squared minus x times minus 2 is positive 2x. Now I've got to expand this bracket here very carefully. So 3x times by 3x is 9x squared. 3x times by negative 2 is negative 6x, but I got it twice, so it's negative 12x. And then negative 2 times by negative 2 is positive 4. That's all equal to 2. So let's try to simplify this as one quadratic. So we've got 2x squared minus 3x squared is negative x squared, plus 8x squared plus 9x squared is 8x squared, beg your pardon. Okay, then I've got 2x minus 12x is negative 10x. And what else have I got? I've got this 4, and I'm going to subtract 2, so that'll be plus 2, is equal to 0. Okay, so here we've got a quadratic. I think, first of all, let's just divide everything through by 2, right? So 4x squared minus 5x plus 1 is equal to 0. And we can factorize this, or, yeah, I mean, for guys who are sitting this exam in the future, you're not going to have a calculator in paper 1. So let's just think about how we can do this. Well, we want 2 numbers that are going to multiply to give positive 1. So there's only one way of doing that, I would say, and that is those numbers have got to be 1 and 1. They've got to combine in such a way that we're going to get negative 5x. So one's got to be positive and one's got to be negative, right? And we're also looking for a combination that gives us 4x squared. So that could either be 4x and x or 2x and 2x. So I think it'll be 4x and x. And what I would do is I would make that negative and negative. Okay, sorry, I made a mistake earlier, didn't I? I said that they've got to multiply together to give positive 1, which means both will be negative. Okay, all right, let's just double check that. 4x times by 4x is 4x squared. 4x times by negative 1 is negative 4x. Negative 1 times by x. So negative 4x minus x is negative 5x. And negative 1 times by negative 1 is positive 1. So that all works. Okay, so then what we've got is we have got 2 values for x. X will either be equal to a quarter or x will be equal to positive 1. But then we need to find the y coordinates of these, right? And the way to do that is we're going to substitute them into 3x minus 2. So y is equal to 3 times by a quarter minus 2. And so that's going to be 3/4 minus 2. 2 is the same thing as 8/4. So 3/4 minus 8/4 is -5/4. Okay. And the same thing for here. We're going to get 3 times by 1 minus 2. And 3 minus 2 is just 1. Okay. So what does this mean? This means that we've got the coordinate A is going to be the point 1/4, comma, -5/4. And the coordinate B is going to be 1, comma 1. All right, so that's the first thing that we've done in this question. Now let's go up. The point C with coordinates k 7/8 lies on the perpendicular bisector of the line AB. All right, well then we probably want to find the perpendicular bisector of AB. Now, what do we mean by perpendicular bisector? We mean the line that runs perpendicular to AB and that goes through the middle of AB. So I think it might just be best if I was to draw it out, actually. So let me do this. I'll do it like that, like that. Okay, so 1/4, 1/2, 3/4, 1. So I made that 1 there. 1/4, 1/2, 3/4, 1. So that's 1 there. 1/4, 1/2, 3/4, 1, so that's -1. Okay, and that'd be -5/4 there. So let's label on the point A. So point A is 1/4, -5/4. So that's that guy there. That's A. Okay, scroll down a little bit. 1/4, -5/4. And where's point B? Point B is the coordinate 1, 1. So B's there. Okay, 1, 1. And so if I was to draw the line A to B, like that, then what we're really being asked to find is to find the perpendicular bisector, which is the line that runs perpendicular to this. Whoop, I'll do it in green. Sorry about that. And that cuts through the midpoint of AB. So that's basically the thing that we want there. Okay, we want it to do that. Okay, so what do we need if we want to find the perpendicular bisector? We need to find the gradient of that line, and we need to find the point that the line goes through. All right, then, so let's get that gradient. Let's get the midpoint as well. So how do we get the midpoint? The midpoint is found by adding up the two x coordinates and dividing by 2. So if we do 1/4 plus 1, we get 5/4 divided by 2 is 5/8. Okay, so that's the coordinate there. And the y coordinate is the same thing. We add up the two y coordinates. So -5/4 plus 1 is going to be -1/4. And we divide by 2. So we get -1/8. Okay. All right, then. So we got the midpoint. Now let's find the gradient of the green line. Well, to get the gradient of the green line, we need to get the gradient of the blue line first. So the gradient of the line AB is going to be y2 minus y1. So that's 1 minus 5/4, which is 1 plus 5/4. And then we do 1 minus 1/4, like that. Well, if we do 1 plus 5/4, that's going to give us 9/4. And if we do 1 minus 1/4, that's going to give us 3/4. So we've got 9/4 divided by 3/4, and that's just equal to 3. So that's going to be the gradient of our blue line there. So what's the gradient of the green line, the perpendicular line? Well, it's going to be the negative reciprocal of that, right? So the gradient of the green line, gradient of the perpendicular, is equal to -1/3. Okay, so now we've got the gradient of our perpendicular bisector. We've got the point that it goes through, which is 5/8 and -1/8. So now really all we've got left to do is to get the equation of the line. And the way we do that is y minus y1 is equal to mx minus x1. where m is the gradient and x1, y1 is the coordinate point. So let's substitute in y minus an eighth, so y plus an eighth is equal to m, which is negative a third, x minus 5/8. And that's the equation of the perpendicular bisector. Now, I'm just going to leave it like that for the moment because I don't really need to get it in the form y equals mx plus c, because the question just says this point C has coordinates k 7/8, and we want to find, and it lies on the perpendicular bisector. We want to find the value of k. So in other words, this coordinate here will satisfy our equation. So k 7/8 will satisfy the equation. So let's write that down. When x is equal to k, y is equal to 7/8. I'm just going to double check that again, just make sure I got it right. Yeah, 7/8. All right. So let's substitute it in. 7/8 plus 1/8 is equal to negative a third k minus 5/8. Okay, well 7/8 plus an eighth is just equal to 1, is equal to negative a third k minus 5/8. Okay, so we times both sides through by, let's times them both through by -3, right? So that's -3 is then equal to k minus 5/8. And so we just got to add 5/8 to both sides. So we get k is equal to -3 plus 5/8. And -3 is going to be the same thing as minus 24/8. So we've got minus 24/8 plus 5/8 is equal to minus 19/8. Okay, so that should be our answer. I'll just double check that. So question 7a, where am I looking? Okay, negative 19/8 is our answer. Okay, all right. Okay, then part B of this question, the point D lies on the perpendicular bisector of AB such that D is a reflection of C in the line AB. Find the coordinates of D. Now, you should notice this is only worth 2 marks. So if you're ending up doing lots of algebra to do it, then you're probably wrong. There's a simpler way of looking at this, and I suggest that what you do is you have a nice, clear diagram. Okay, so let's go back here. So we have got the green line. The green line is the perpendicular bisector of AB. And we're told that C lies on that line, doesn't it? So C was the point, was it negative 19/8 and 7/8. So I don't know, we'll put it here, right? So that's point C, which is negative 19/8, 7/8, right? That's that point. The midpoint is this guy here. So I'll write it like that. 5/8, comma, negative an eighth. And we want to find the point D, which is the reflection of C in the line AB, right? Just make sure I understand that. Yeah, it's a reflection in the line AB. So this point is going to be reflected in that line. So it's going to go to somewhere over here, right? So this is point D, the coordinates of which at the moment are unknown. However, if it is a reflection in AB, then basically what we can say is that that distance there horizontally to that distance there vertically will be the same as this, right? In other words, to go from C to the midpoint, I move a little bit to the right and a little bit down. So then to go from the midpoint to point D, the reflected point, I'd have to go the same distance across and the same distance down. So I just got to figure out basically what those distances are. Well, horizontally, this is negative 19/8 all the way to 5/8. So what's that total distance going to be? It's going to be 24/8. Right, so this guy here is going to be 24/8 I'm moving across, which means over here I'm moving 24/8 across as well. What about going down? This is the coordinate 7/8, right? And I'm moving down to negative an eighth. So what's the total distance there? It's 8/8, or just 1. I'll write it as 8/8 for the moment. Okay, which means over here I'm moving down by 8/8 as well. So how do I get the x coordinate of D? Well, I go from 5/8 and I add 24/8. So that would give me 29/8. And I go from -1/8 here in the y coordinate, and I go down by 8/8, which would be -9/8. Okay, so by just applying that, I should have been able to find the coordinate of D. So 29/8 and -9/8. Let's just have a quick look at the answer. We go to there. 29/8 and -9/8. Yeah, exactly right. Okay. If you prefer, this is kind of like doing vectors, isn't it? Basically, what we're really saying is that the vector c to m, which is equal to 24/8, -8/8, right? Or if you prefer 3, -1, right? That's the vector, is the same thing as the vector going from m to d. Okay? So I can think of it that way. All right? Okay, then question 8. A curve has got this particular equation here. We want to show that dy dx, the derivative of this, can be written in this form here, where a, b, and c are integers. Okay, look, this thing here is a quotient rule. And the reason is because we've got one function, this guy on the top, divided by another function on the bottom. Now, what is the quotient rule? The quotient rule is v du minus u dv all over v squared. Okay, so vu prime minus uv prime over v squared. I suggest that you learn a quick way, by the way, to say it to yourself so that you can easily remember it, right? So v du minus u dv upon v squared, I think is quite a fast way. The commonest error is to get these two guys the other way around, right? People say it's u dv minus v du, and that's the error I most often see. And the reason for that is because students memorize the product rule in that order. So I suggest that what you do is actually you remember the product rule in the same order as the quotient rule. So if the quotient rule is v du minus u dv, then you remember the product rule as v du plus u dv, right? So basically, you want to avoid making the mistake with the quotient rule. I think the best way to do that is actually just to memorize the product rule differently, but it's up to you. Okay, what's our u? Our u is this thing here, the 3x squared minus 5 to the power of a third. And what's our v? Our v is x plus 4. So we need to differentiate both of these, basically. So if I differentiate u, then I differentiate the big bracket, right? So that means that the third comes to the front, and I reduce that power by 1. So I'm going to get a third bracket 3x squared minus 5 to the power of -2/3. And then what I do is I differentiate inside the bracket. So if I differentiate 3x squared, I get 6x. And I'm going to multiply through by 6x. Okay, and just in case you thought I missed it, -5 differentiates to 0, right? So this whole thing inside the bracket differentiates to give 6x. Now, we can simplify, can't we? Because a third times by 6x is going to be 2x. So I'm just going to get rid of that here. So we can just get rid of that. Okay, so I'm going to put 2x at the front instead. Okay, 2x. Okay, now if I differentiate v, that's just going to give me 1. Okay. All right, so now I think what I need to do is just need to substitute into the formula for the quotient rule. So v is x plus 4. U prime is 2x bracket 3x squared minus 5 to the power of -2/3 minus u, which is 3x squared minus 5 to the power of a third times by dv, which is 1, right? I always write it, even though it's kind of unnecessary. It's just good to show my working, okay? Then we divide it by v squared, which is x plus 4 all squared. Now then, the difficulty is going to come with simplifying this. Now, essentially, the trick is you look at this guy here, right? This has got a negative power. So I want to eliminate him. How could I eliminate him? Well, if I multiply the entire numerator by the same term but with a positive power, right? If I multiply it by 3x squared minus 5 to the power of +2/3, then what's going to happen is, as I multiply it, those powers are going to add. So I get -2/3 plus 2/3, which is 0, and anything to the power of 0 is 1, right? So that term will cancel off. And then over here, I've got a power of a third plus a power of 2/3, which is a power of 3/3, which is 1. So in other words, I'm left with just 3x squared minus 5 to the power of 1. So if I write this all out, I have got x plus 4 times by 2x times by 1, right? Because that's what happens to this term here, minus 3x squared minus 5 to the power of 1. And then, of course, I need to recall that if I multiplied the numerator here by this term in blue, then I also need to multiply the denominator in order to have equivalent fractions. Right, so on the bottom, what I'm going to have is I'm going to have this thing here. Sorry about that. X plus 4 squared times by 3x squared minus 5 all to the power of 2/3. All right, now let's simplify all this thing. Let's expand the bracket. X times by 2x is 2x squared, minus 3x squared is minus 1x squared. So we've got minus x squared there. 4 times by 2x is 8x. Okay, so that's just plus 8x. And then right at the end, we got minus 5, which is plus 5. And this is all going to be divided through by x plus 4 squared. So x plus 4 squared. And then now we've got to just think to ourselves, what does this thing here mean? What does that power mean? Well, the third means we've got the cube root of this term squared. So I will write that as 3x squared minus 5 squared, and then all cube rooted. Okay, and I think that's what the form that we want. Yeah, in the end. Okay, oh, actually, they don't even bother to write it as a cube root. Never mind. So our A, I think, is -1. Our B is 8, and our C is 5. So let me just check the answer in the mark scheme, see if that is correct. So we're looking at question 8. Let's just go back. -1, 8, and 5 is the correct answer. All right, then. Let's go to part B. Hence, find the x coordinates of the stationary points of the curve, giving your answer in the simplest terms. Okay, well, when do we get a stationary point? Right, so part B, a stationary point is when dy dx is equal to 0, because it's where the gradient is 0, right? So I'm going to set 0 is equal to -x squared plus 8x plus 5, right? I can ignore the denominator, right? Because if I set the whole thing equal to 0 and I multiply through by this side, it'll get multiplied by 0 and just disappear. So I can ignore that. I'll simplify this a little bit. So x squared minus 8x plus 5. Now, the question says, give my answer in exact form. So it's not going to factorize. We're going to have to use the quadratic formula. So let's use that. X is equal to minus b. So that's minus 8 is plus 8. Plus or minus the root of b squared, so -8 squared is 64, minus 4 times by a, which is 1, times by c, which is 5. I'm just trying to make sure that I've got that right. I've got it wrong, haven't I? Sorry, because I did this question earlier, so I remember that's not quite right. That's a negative, sorry, because I multiplied this whole thing through by -1. So the -x squared becomes positive x squared, positive 8x becomes -8x, and positive 5 should become -5, which means that that guy there is a -5. All right, okay, good. All divided through by 2a. So a is 1, so we get 2 times by 1. So now let's simplify all of this. So I've got 8 plus or minus 64, right? If I multiply this out, right, I'm going to get -4 times by -5 is positive 20. So 64 plus 20 is 84. All divided by 2. And can I simplify 84? Well, that looks like to me I can divide it through by 4. I think if I remember. So 4 times by 21 over 2. And of course, if I square root the 4, I get 2. So that's 8 plus or minus 2 root 21 upon 2, which is the same thing as 4 plus or minus root 21. So your two answers are 4 plus root 21 and 4 minus root 21. And I'll check the answer. And yep, that is exactly right. Okay. Okay, then question 9, a kinematics and vectors style question. Particle P moves with a speed of 14.5 parallel to this vector here. Want to find the velocity vector of P. Okay. All right. Well, let's think about this vector here. That vector is moving, let's say something like that, right? So that's that vector. We'll call it B. So B is equal to negative 20, 21. And what we know is our velocity vector is going to be moving in the same direction as that. So first point, this thing isn't the velocity vector, right? This is just telling us the direction that our velocity vector will be going. We know that our velocity vector will be heading like that, but we want to find the correct size. And we know that the size of our velocity vector must be 14.5. Why is that? Key point for you to remember, speed is the same thing as the magnitude of the velocity vector, right? So the velocity vector. Sorry to write that in shorthand. So basically what we're looking for is we're looking for a vector which is in this direction, right? This direction here, but which has a magnitude of 14.5. So what we're going to do is we're going to find the magnitude of this vector here and see what it is. And then we've got to scale it so that we get 14.5. So let's take the magnitude of negative 20, 21. And if we find the magnitude of that, that's going to be the square root of negative 20 squared plus 21 squared. And if we do all of that, we're going to get 29. Okay? So then, this vector here has got a magnitude of 29, but we don't want it to have a magnitude of 29. We want it to have a magnitude of 14.5. Okay? So how do we go from a vector of size 29 to a vector of size 14.5? Well, we have to divide by 2, right? So if we divide by 2, what we're going to end up with is that vector there, right? Because what I'm trying to say is the blue vector has got a size of 29, and we want this vector here to have a size of 14.5, so we just divide it through by 2. So in the end, our velocity vector is going to be negative 10, 10.5. Okay, so sorry to labor that. I think, it's a slightly long explanation for just 2 marks, but I often get asked this question. The key thing for you to understand is that speed is the magnitude of the velocity vector. And so for you to find your velocity vector, what you need to have is the correct direction, but also the correct magnitude. Okay? All right. Next part, part B. Initially, P has position vector 3, 5. Write down the position vector of P at time t. Now, the position vector of a particle is given by this formula. R is equal to A plus VT. Okay? Where A is the initial position, so in this case it's 3, 5, and V is the velocity. Now, this is probably just best demonstrated if I was to draw a diagram, right? So let's say here we've got our origin point, so we're measuring displacement from here, and I'll draw the vector A. Okay, so here's the vector A, like that, and that takes us to where the particle starts, right? So let's say the time here is time is equal to 0. So first thing really to understand is displacement is 0 here, but the time where we start is 0 there, right? So they're not the same thing, right? Time is not 0 here. Time is actually 0 over here. And then our object moves in this direction, right? So let's say the object moves in that direction. Well, if the object moves in that direction, what that means is the velocity vector is pointing that way. Okay, so this is the direction of the velocity vector. Okay, so how are we going to define where our particle is? Well, firstly, we've got to get to the starting position. So we move along the vector A. And then imagine if we travel for 1 second, we're going to move 1 step in the direction of V. 2 seconds would be 2 steps. 3 seconds would be 3 steps. 4 seconds would be 5 steps, and so on. In other words, the position that we are at any point in time is basically dependent upon how long we've been traveling along that blue line, right? So we know that we're going to go a plus the velocity times by however many seconds we've been running, right? So 1 second there, 2 seconds there, 3 seconds there, 4 seconds there, okay? So hopefully this diagram should basically make sense to you, and therefore this formula should make sense to you. And if you really understand that, then basically in any of these questions, what you're looking for is you're looking for your starting position, right? Your initial position A, and you want your velocity vector, which we got in the previous question, right? This is the velocity vector. And so then you just join them up and you say that R, or in this case, I'll call it OP, right? The position of P is equal to 3,5 plus V, which was what? Negative 10, 10.5 times by T, okay? All right, guys, now, can I strongly suggest that you try to understand what that formula is, right? So you memorize it because it comes up a lot, but also you got to try to intuitively understand what it means, right? A means take you to the position where you start, where time is 0. VT is basically walking along that line for t seconds. Part C. A second particle has position vector, blah, 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 at time t. Well, if we look at this, what would that vector there be? That vector would be our initial position, right? That's our A vector. What would this vector be? This would be our velocity vector, right? So Q starts here and moves with that velocity. Okay, question. Find in terms of t the distance between P and Q at time t and simplify your answer. Well, again, I think it's best just to draw a diagram. Here's our origin point. Let's imagine that P is here at some point of time and whatever Q is here. Okay, so I'll draw the vectors like that and like that. Okay, so this vector here, right, is going to be OP, and this vector here is going to be OQ. And what are we being asked to find? We're being asked to find the distance between P and Q. In other words, we're being asked to find this distance here, right, from P to Q. Well, what would that distance be? That distance will be the same as the magnitude of the vector P to Q, right? So if we can find the vector from P to Q, right, then the length of that vector will be the distance PQ, right? The magnitude of that vector will be the distance PQ. So first order of business is to find PQ. All right, well, we already know that OP is equal to this guy here, right? 3,5 plus negative 10, 10.5t. So let's write that down. 3,5 plus negative 10, 10.5 times by t. And we know OQ, because it's given there in the question, is negative 1, 3 plus negative 5, 7.5 times by t. So what will P to Q be? Well, P to Q is the same as OQ minus OP. And if you're not sure about that, let's just look at our diagram, right? P to Q, I go negative OP, right? Because I'm going in the opposite direction. So I've got negative OP, that's that thing there. And then plus OQ, that's that thing. So OQ minus OP or minus OP plus OQ takes me there to there. All right, so now I've just got to do this subtraction basically. I'm going to do this vector minus that one. So I'm going to get negative 1, 3 minus 3, 5. Well, if I do that, I'm going to get negative 1 minus 3 is negative 4. 3 minus 5 is negative 2. And then same thing over here, right? I'll do this thing minus that thing. So negative 5t minus 10t is positive 5t. And 7.5t minus 10.5t is minus 3t. So I'm going to get that thing there. Okay, then I'm going to combine this all together. So I'm going to write this as negative 4 plus 5t and negative 2 minus 3t. So that's my vector P to Q. And what did I say? I want to find the distance from P to Q. So what I'm going to end up doing is I'm going to find the magnitude of this vector. So the magnitude of P to Q. Well, how do I do that? Well, I'm going to do this thing squared plus this thing squared, all square rooted. All right, so let me do that. So all square rooted, this whole thing square rooted. So you got negative 4 plus 5 t all squared plus negative 2 minus 3t, negative 2 minus 3t all squared. Okay, let's expand this all out. So we're going to get the square root of negative 4 squared is 16. Negative 4 times by positive 5t is negative 20t. Doubled is negative 40t plus 25t squared. And negative 2 squared is positive 4. Negative 2 times by negative 3t is is positive 6t. Doubled is positive 12t. And then negative 3 all squared is positive 9t squared, right? So that's all of that. So now let's simplify this. We have got 25t squared plus 9t squared is 34t squared. Negative 40t plus 12t is negative 28t. And then we've got 16 plus 4 is 20. Okay, so we've got that thing there is the distance from P to Q. So I think that's the question that we're being asked to find. Yeah, so that's that. All right, now have we got the last part? Okay, D, hence show that P and Q never collide. Well, let's think about that. If they do collide, then the distance between P and Q must be 0, right? So let's write that down. If P and Q collide, then the distance between them must be equal to 0. So let's put that in. Let's then say that 0 is equal to the square root of 34t squared minus 28t plus 20, right? Square rooted. But of course, then if we square both sides, then we get rid of that square root. So let's just do that. Okay. And I think this will divide, won't it? This should divide through by 2 at least. So 17t squared minus 14t plus 10. Okay. And can we show basically that this is never ever solvable? How can we show that it's never solvable? Well, we can find the discriminant because this is basically a quadratic. So we're going to do the discriminant b squared minus 4ac is equal to negative 14 squared minus 4 times by 17 times by 10. Okay, and if I stick that all into a calculator, I get negative 484. Okay, so the key thing there is the discriminant is negative, right? Negative. So there are no real solutions to this quadratic, and hence particles do not collide, right? P, Q do not collide. Okay, now I just noticed in the mark scheme that the discriminant that they've got isn't negative 484, it's another number. But the reason it's another number is because they didn't divide through by 2 here. They didn't simplify it. Okay, I did. So what you'll notice is that the answer in the book, I think, is 4 times the one I've got. But it doesn't matter. The conclusion is still basically the same. Okay, all right. Okay, question 10. The first 3 terms of an arithmetic progression are blah, blah, and blah. Show that the sum to n terms of this arithmetic progression can be written in the form of this, where a is a constant. Now, an arithmetic progression is where we are adding the same term each time. In other words, we've got a common difference. So if we look at this progression, the first term is 3 sine 2x. And what is it that we're adding each time? We're adding, well, to go from 3 sine 2x to 5 sine 2x, we need to be adding 2 sine 2x, right? So that's what's going on there. Now, the sum of n terms in an arithmetic progression is given by the formula, which I think is on the front of your book, n upon 2 bracket 2a plus n minus 1 d. Okay, so what we can do is we can just substitute in, right? So we're going to have n upon 2 times by a, so that's going to be 6 sine 2x plus n minus 1 times by d, which is 2 sine 2x. Okay, so then let's expand this all out. So we're going to get n upon 2 we've got 6 sine 2x minus, right, 2 sine 2x. So that'll be 4 sine 2x, and then plus 2n sine 2x, right? Because I expand the n there times by the 2 sine 2x. Well, then if I multiply through the n upon 2, then here I'm going to get 2n sine 2x, and here what I'm going to get is plus n squared sine 2x. All right then, what form do we need? Oh, they want it to be factorized. Okay, well if I factorize out n, I'm going to get n sine 2x, open bracket, 2 plus n. Okay, so if I just go up, that guy there, that a is going to be 2. Okay, sorry, just to make it absolutely clear, right? This is n bracket n plus 2 times by sine 2x. Okay, all right, next part, part 2. Given that x is equal to 2 pi upon 3, find the exact sum of the first 20 terms. All right then, the sum of the first 20 terms means n is equal to 20, so we're going to get here 20 times by 20 plus 2, which is 22, times by sine 2x. Okay, so 20 times by 22 times by sine 2x. All right, so then we are going to have sine, if we substitute in 2 pi by 3, we're going to get sine 4 pi by 3. Okay, now I need to recall what that is. Okay, so if you put that into a calculator, you get negative root 3 upon 2. I thought it was going to be something like that, but I just didn't want to make a mistake, so I just put it into the calculator. Negative root 3 upon 2 there. And I think we can simplify that. Let's divide top and bottom by 2, so that becomes 10, and that disappears. So we've got negative root 3 times by 22 times by 10. So that's going to be negative 220 root 3. Okay, so let's just check that against the mark scheme. So question 10, isn't it? Yeah, negative 220 root 3. Okay, so this is part B. The first 3 terms of a geometric progression are ln 2y, ln 4y squared, and ln 16y to the power of 4. Find the nth term of this geometric progression. Okay, now, with a geometric progression, what's happening is we are multiplying each time. We have a common ratio, not a common difference. So I think what we want to do is we want to be able to see that, and the best way to see that is to rewrite these terms to make that a bit more clear. So this is what I'm going to do. We've got ln 2y, and then the next term can be written as ln 2y squared, and then the next term after that can be written as ln 2y to the power of 4, right? So just double check that. 2y squared is equal to 4y squared. 2y all to the power of 4 is 16y to the power of 4. And if that's the case, then the series can be written as ln 2y and 2 ln 2y and 4 ln 2y. So why is this a geometric progression? Well, because if you notice, what we're doing is we are multiplying by 2 each time, right? I multiply by 2 and I multiply by 2. So for any geometric progression, we need the first term, which is ln 2y, and we need the common ratio, which is 2, okay? And so how can we get the nth term? Well, the nth term of a geometric progression, un, is equal to a times by r to the power of n minus 1. And so we're going to get ln 2y times by r to the power of n minus 1. So 2 to the power of n minus 1 times by ln 2y. All right then, let's go down. Find the sum to n terms of this geometric progression, giving our answer in its simplest form. Well, the formula for the nth term of a geometric progression, which is on the front of your paper, is a bracket r minus, sorry, r to the power of n, beg your pardon, minus 1 all over r minus 1. So again, what we're going to do is we're just going to substitute in our value for a and r. A is ln 2y. R is 2, so we get 2 to the power of n minus 1 all over 2 minus 1. And of course, 2 minus 1 is just equal to 1. And so we can simplify that. Okay, and that will give us just 2 to the n minus 1 times by ln 2y. All right, part C of this arithmetic geometric progression question. The first three terms of a different geometric progression are this, this, and this. I want to find the values of w for which this geometric progression has a sum to infinity. All right, so firstly, we have got a geometric progression. Now, a geometric progression, as I said in part B, is one in which we are always multiplying by some common ratio. So if we've got the first term u1, and the second term u2, and the third term u3, and so on and so on, what we're doing is we are multiplying by some common ratio always to get to the next term, right? Now, what that means is that it means that the common ratio can be found either by doing the second term divided by the first term, or by doing the third term divided by the second term, or the fourth term divided by the third term, and so on and so on and so on, right? So in other words, if I was to take this term here, the second, and divide it by the first, I should get the same value as this term here, the third, divided by the second, right? So that is exactly what I'm going to do. Okay, and if I do that, hopefully what you can see is the common ratio is going to be, oh, I'll do it in full, right? So 2w minus a quarter squared over 2w minus a quarter. Right, so that's the second term divided by the first term. Well, we can cancel off, can't we, by dividing top and bottom by 2w minus a quarter. So what we're going to get is the common ratio is equal to 2w minus a quarter, like that. Whoop. Right, that's the common ratio. Now then, sum to infinity. What does sum to infinity mean? Well, basically what it means is that you're adding up all these terms, and you keep adding as if you've got infinitely many terms, and the summation is actually going to reach a fixed and finite value. Let me give you an example of that. Okay, so here's an example. Let's say we've got 4 plus 2 plus 1 plus a half plus a quarter plus an eighth, and so on and so on and so on, right? It just keeps going on and on and on to infinity. Now, this is a geometric progression with the first term 4 and a common ratio of a half, right? Because every single term is dividing by 2. If I was to add up these terms, eventually over here, the terms are getting so small that they basically equal 0, right? So it's like I'm adding on a small number. I'm basically adding on 0 plus 0 plus 0 plus 0. So the summation will be fixed. The sum will reach some fixed value, right? And we call that the sum to infinity. Now that will only work if the common ratio is between 1 and -1, right? Because in other words, we need the terms to be getting smaller. And the only way that the terms will get smaller is if the common ratio is between 1 and -1, okay? So we've got our common ratio is 2w minus a quarter. So basically what we're saying is 2w minus a quarter must be between 1 and -1. So we're just going to rearrange this inequality. So I'm going to add a quarter to both sides. So if I add to all the sides, beg your pardon. So if I add a quarter, that's going to become -3 upon 4. Okay. And this will become 5 upon 4. And then I'm going to divide everything through by 2. So this becomes -3 upon 8. And this will become 5 upon 8. So in order to get the sum to infinity, w must be between -3/8 and 5/8. Okay? Yeah, that's exactly right. Okay, thank you. Thank you very much. All right, then the last question. Given that y is equal to x squared ln x, find dy dx. And then part B is hence find the integral of this, right? So it's a kind of classic question. You differentiate something, and then in part B, you reverse the differentiation to find an integral. All right, so how are we going to do part A? The first thing to notice is we've got two functions multiplied together. We've got x squared multiplied by ln x. So we've got the product of two functions, and therefore we use the product rule. Okay, that's the key thing, right? If you've got the product of two functions, you use the product rule. What is the product rule? The product rule is v times by du dx, or v times by u prime, plus u dv dx, right? So v du plus u dv. And I prefer to memorize it in that order because it's the same order as the quotient rule, right? The quotient rule is v du minus u dv upon v squared. Okay, so basically what we need to do is we need to identify our u and our v, and we need to differentiate them. So our u will be x squared, and our v will be ln x, which means that u prime is going to be, we differentiate x squared to get 2x, and then we differentiate ln x for our v prime, and that gives us 1 upon x. So now we can just substitute into the formula for the product rule. So we're going to get v times by du, so we're going to get 2x ln x plus u dv, so we'll get x squared times by 1 upon x, so x squared times by 1 upon x, and that is equal to 2x ln x plus x. Okay, and can I just advise you, whenever you're doing this, always make your working super duper duper clear. In case you make a small error, the examiner can award you the method marks appropriately. Okay, now then, part B, hence. Now, whenever you've got this situation, basically what you want to do is you want to take part A and rewrite it as an integral, right? So let me try to explain that. If you differentiate this function here and you get that function, what it means is that if you were to integrate this thing, you would go back to that, right? Because integration is the reverse of differentiation. And so in order to get a method mark, basically, that's exactly what I'm going to write. I'm going to make sure that I write this thing here as an integral. So I'm saying that if I integrate 2x times by ln x plus x dx, that will be equal to the thing I differentiated in the first place, which is x squared ln x squared ln x plus the constant c. Okay, so guys, can I just really strongly suggest you always do that step at the very, very beginning. It is basically a way of guaranteeing that you will get a mark at least. Okay, so it kind of frustrates me when my students don't do that. They try to be too clever. No, don't be lazy, basically. Make sure you get the mark that's there waiting on the table for you. Okay, now, having done that, we want to basically isolate the integral of x ln x, which is going to be that term there. Okay, it's this guy. So we just highlight it for you. We want to get that guy all by itself. How are we going to do that? Well, firstly, we've got to split off this x. So we're going to split up the integral. So we're going to get the integral of 2x ln x dx plus the integral of x dx, okay, is equal to x squared ln x plus c. Can you see that? So what we've done is we've taken that one integral, we've split it up into two separate integrals. Then what we can do is we can take that 2 and bring it outside of the integral. Why? Because it's a constant, right? So the constant can come straight out. So we get 2, the integral of x ln x dx. And then if we integrate x, we're going to get x squared upon 2 is equal to x squared ln x plus c. All right, then. The only thing that remains for us to do is just rearrange this guy. So 2 times by the integral of x ln x dx is equal to x squared ln x minus x squared upon 2 plus c, right? So I bring the x squared upon 2 to the right, and then I'm going to divide both sides through by 2, right? Because I want to get rid of that 2, basically. And if I do that, I'm going to get the integral of x ln x dx is equal to a half x squared ln x minus a quarter of x squared plus c. Okay, all right, guys. Now I hope that was helpful. I think, to be honest, those questions are usually quite tricky, but in this particular case, actually, I don't think it's so bad. so long as you sort of understand the basic principle. Okay. All right. Now, if you found this video and other videos I've done helpful, please like and subscribe, share with your friends, and I look forward to seeing you next time.